So our problem is giving us atoms of phosphorus, 4.7 times 10 to the 25th atoms, in a sample of potassium phosphate. Now we notice that the molar mass is given, otherwise we'd have to calculate that as well. And it says, what is the mass of potassium phosphate? Now we've got the molar mass, but we don't know the moles of potassium phosphate, so we can't actually just do a simple moles to grams calculation. So we have to take the information that's given, in this case, the atoms of phosphorus, and we're going to convert that to moles of phosphorus. Okay, because remember what I said, if you don't know what to do on a problem, convert to moles. Chances are it's going to be the right thing. So I can get from atoms of phosphorus to moles of phosphorus. Now, I can also go from moles of phosphorus to moles of the potassium phosphate. So I actually have to have the formula for that. And right now I'm just going to write the compound down here. And then once I have moles of the compound, then I can get to grams of the compound. So I can get from atoms to moles using Avogadro's number. I can get from moles of phosphorus to moles of the compound using the ratio in the formula, which we're going to find in just a second. And then I can get from moles of the compound to grams of the compound using the given molar mass. So the first thing we have to do is actually find the formula for the potassium phosphate. We're given the name. So the first thing we're going to do is figure out what the charge is on potassium. And that's going to be +1, so I'm just going to write it as a plus. And then I need to look at phosphate. And the formula for phosphate is PO4. And it has a charge of 3-. So now, just like my other ionic compounds, I can simply do the crisscross down, and I find that the formula is K3PO4. I don't need to put parentheses in the formula because the subscript for the phosphate is just 1, so I can leave those out. Now I have the formula potassium phosphate, and if I wasn't given the molar mass, I could have then calculated that from the formula. But what I'm actually going to be using the formula for is the step here to get from moles of phosphorus to moles of the compound. So we're given atoms of phosphorus, we're going to moles of phosphorus, moles of the compound, and then grams of the compound. Now let's start with the number we're given, which is 4.7 times 10 to the 25th atoms of phosphorus. And I'm going to use my Avogadro's number to get from atoms of phosphorus, so 6.022 times 10 to the 23rd atoms in 1 mole of phosphorus. So now if I look at my units, I see that atoms of phosphorus cancels out. And if I stopped here, I'd have moles of phosphorus, but that's not where I want to be. I want to get to the moles, ultimately the mass of potassium phosphate, which means I first need to get to the moles of potassium phosphate. Now I can use the ratio in my formula, which we determined was K3PO4. So now I can set up a ratio here, and for every 1 mole of phosphorus, I have 1 mole of K3PO4. So that's the ratio I get from the chemical formula that I found based on the charges of the ions. Now, if this were oxygen, I had atoms of oxygen, then I would have to use a ratio of 4 moles of oxygen to 1 mole of the compound. Because phosphorus has a 1 as a subscript, I can say 1 mole of phosphorus to 1 mole of the compound. Now my moles of phosphorus cancel, and I'm actually going to continue this on the next line. I'm out of room there, so we're going to bring it around to the next line. Now I have moles of potassium phosphate for my units, and now I can use the molar mass that was given, and I have 212.27 grams per mole of K3PO4. So I can look at my units now. Moles of potassium phosphate are going to cancel out. What I'm left with for my units are grams of K3PO4, which is exactly what's being asked for in the problem. Okay, that's what we're asking for, so that works out well. Now it's just a matter of doing the mathematical calculation. When we do the calculation, we get our answer to be 1.7 times 10 to the 4th grams of potassium phosphate. Notice we can only have 2 sig figs here because our number of atoms up here, 4.7, only has 2 sig figs. So our molar mass has 5, but we have to go with the least number of sig figs. So when we look at chemical formulas, remember that we can use them also to set up ratios. So in this case, we could set up ratios between the potassium and the molecule. So 3 potassium and 1 mole of the compound, 1 mole of phosphorus, 1 mole of the compound as we used in this problem, or 4 moles of oxygen to 1 mole of the compound.